Hello, I'm glad you made it back. In this video, we will cover the differences between explicit and inferred types. Swift is a typed language, so when we assign a constant or a variable a value, it is actually being assigned a type as well. Let's start with a new playground again. This will give us our default var str equals hello playground. If we alt-click on this str, we get this question mark. Well, if we just hover over it with the alt, we'll get the question mark, and then if we click on it, it will tell us that this is a var str, and it has this colon and then string. This string is its inferred type. Notice we didn't put that colon string like we have in the previous videos when we worked with our doubles. This is just saying that we have a string on the right hand side, which is this hello world in quotes, and Swift knows how to take that value and it knows how to infer the type. So this is an inferred type of string. We could explicitly define the type by saying var str1 and then doing the colon space string and set that equal to hello playground. So these two values are the same exact thing, except one has the inferred type and one has an explicit type. So when we work with numbers, it's slightly different. So if we do a var number, and we say this number is going to be equal to 42, this by default will get a value or a type of int with a value of 42. So if we alt-click, we can see that the inferred type is an int. But say we wanted this 42 to be represented by a double. There's two ways we could do it. We could explicitly define the type as a double by doing a colon and then double. And then 42 can be represented by the double. And it will actually be represented by 42.0. So if we do print number, it will print 42.0 in the console. Instead of explicitly defining this double, we could also have it infer number to be a double by saying 42.0. And now when we print the number, it will still print 42.0 because it's now inferred as type double. But say we later wanted to assign this number to an integer value. Let's say var int number equals our number. We can see that if we alt-click on number, it's double. And now if we alt-click on int number, it's also double. But if we want that to be an int, we can say int, open parenthesis, wrap number, and then close parenthesis. And that will convert our number that is type double to an integer value of that number. So now if we alt-click on int number, it is an integer, and we can confirm that by printing our int number to the console. Then we get 42. So let's go over a little bit more advanced example. We will create a dividend. We'll set that equal to 15, and then we will create a divisor and set that equal to 3. And then we will have our quotient, which will be our value, and we will do dividend divided by divisor. So now if we print our result of the quotient, we will see we get the value of 5. And this value of 5 will be the inferred type of an integer because 15 divided by 3, they're both integers being divided by each other. So our inferred type for quotient will be an integer. And we can confirm that by alt-clicking on quotient, and it's of type int. So if we change this 3 to a 4, we get unexpected results. So now we're getting the value of 3 as our quotient. And that's because when you do integer division, it does not account for any of the remainder. So 4 goes into 15 3 times when we're doing integer math. So if we now convert the dividend and the divisor to doubles by wrapping it in these open and closed parentheses and putting double before it, we can see that 4 really goes into 15 3.75 times. And our quotient is now of type double. And it's an inferred type, but it's getting that inferred type because we are converting the dividend and the divisor to doubles. Now there may be some other times that you want to convert something into some other type. For example, say we wanted to print our quotient as a string, and we did var string from number, and we set that equal to quotient. But right now, quotient is a double. So we need to first convert that to a string, and we can say string quotient, like so. And now this holds a value of string, so if we just do print string from number, it will print out the string of 3.75. But it still looks like a double. But notice on the right hand side here, first it has it in quotes, and it has this /n, and this is an escaping character, and that n is just saying a new line. So it's just printing this out and going to the new line. We can also confirm, if we alt-click on string from number, that this is in fact a string. But there's also something called string interpolation, and that will convert our quotient from a double or int into a string, but it will do it inline. So instead of explicitly saying string with the open parenthesis quotient with the closed parenthesis, we can wrap it in quotes and then do the / quotient, end the parenthesis, and then end the quote. And this is the same thing as saying the string quotient above, but what this allows us to do is say the result is colon, and it allows us to just put that quotient inside of a sentence that we already defined, and now we can print our string from number 1, and that will give us that whole result. And notice down in the console we have the result is colon space 3.75. In our next video, we will go over managed program flow. This will allow us to make decisions in our applications instead of executing our code in a linear path.